Sometimes it's easier to identify patterns of data sets by looking at a graph of the frequency distribution. Let's just take a look at three of the most common types of graphs that are used, and those are histograms, frequency polygons, and ogives. And let's take a look at what they represent and how to construct them. The first type of graph that I want to talk about is the histogram. The histogram is a graph that displays the frequency distribution using contiguous vertical bars of various heights. The rectangles that create the bars are drawn in such a way that their bases lie on a linear scale representing different intervals, and their heights are proportional to the frequencies of the values within each interval. So essentially what that means is we create a graph using the frequencies for which our data occurred, and then we draw a bar to represent the height for however often our data occurred. We can use a histogram when we have an extremely large set of data because the histogram is used when we clump our data into groups, and each bar will represent that group. It's really useful for visualizing changes of data because we can see where there are peaks, and we can see where there are low points, and we can also see where there may be outliers or clumps of data that just don't sit near the rest of data sets. One term that I'd like you to be familiar with is a bin. Not a lot of people use the term bin. Often they just call them groups. But we're going to call it a bin because we use Minitab in my class. And in Minitab, they refer to those groups as bins. So the class size, or the width of the rectangle in a histogram, is going to be referred to as a bin. So these are the groups that we use to draw our bars. Now when we draw our histogram, we use the familiar X and Y axis. In our histogram, the X-axis is the range of data subdivided into bins. The X-axis, as always, is our horizontal axis, or the axis that goes from left to right. The Y-axis is the frequency, and that is our vertical axis. Here is an example of a histogram that's showing the record high temperatures in each of the 50 states. Notice the bins along the horizontal axis, and notice the frequency along the vertical axis. Here I have my frequency distribution constructed. I have my bins located in one column and the frequency that occurred in the other column. I've created a bar to represent each frequency. Notice this frequency of 2 is very low and corresponds with 2 over here on my y-axis. I then have a frequency of 8 and a bar at a height of 8. I then have a much taller bar at 18. I drop back down to 13 and then 7 and 2 bars that are equal at 1. The next type of graph that I'd like to talk about is a frequency polygon. The frequency polygon uses lines to connect points that are plotted at frequencies for the midpoints of the classes. So we still have to look at our classes, or bins, but this time we need to find the midpoints of those bins and plot those on the graph. The frequency polygon and the histogram are two different ways to represent the same data. When we plot a frequency polygon, on the x-axis, we plot the midpoint of each class. So along the horizontal axis, we find the midpoint and plot those dots. Now remember, the formula for midpoint is the upper boundary of a class plus the lower boundary of a class. That value should be divided by 2, and then you'll have your midpoint. The y-axis is still your frequency. So here is an example of a frequency polygon, using that same set of data that we looked at a moment ago. The midpoint of each bin is found. If I were to add 104.5 plus 109.5 and divide that by 2, I get 107. That is the midpoint of this second class right here. So I would put a dot at 107. Similarly, for each class, I make a dot and connect them at the frequency that corresponds to that midpoint. Notice at 112, I made a dot at 18, the frequency that corresponds to the midpoint of 112. We draw a line to connect these dots. So notice along the bottom I see my midpoints, and along the y-axis, I see frequencies. That constructs your frequency polygon. The last graph is your cumulative frequency graph, also known as your ogive. If you want to describe the number of data entries that are equal to or below a certain value, then you can easily do so by constructing the ogive. This graph uses the cumulative frequencies that were found in your frequency distribution. On the x-axis, you take the class boundaries and list each one once, starting with your lowest lower class boundary. On the y-axis, you create an appropriate scale that will encompass each of your cumulative frequencies. However, you don't use the cumulative frequencies themselves, because this would not give you an evenly dispersed distribution. You want to use an evenly dispersed scale that will encompass your cumulative frequencies. You'll need to look at your cumulative frequencies and decide what scale that will be. You'll use something like 0, 1, 2, 3, or count by fives, 5, 10, 15, 20, or if you're using larger numbers, you may need to count by 100s or thousands. Here is an example of an ogive. Notice the boundaries along the horizontal axis and the scale along the vertical axis. Along the bottom, we've started with the lower boundary and ended with our upper boundary, but we've listed each one only once. We've found our cumulative frequency. We've started with 0 at less than 99.5 and added each subsequent frequency to find our running total. Remember, our cumulative frequency should end with the total number of data points we had in our set. Once we've plotted each point, we connect it with a line, and we'll have our ogive. The scale we used along this axis was counting by fives, because that would encompass our cumulative frequency nicely. Shown below are two additional types of data displays that are widely used. One is the stem and leaf plot, and the other is the box plot. They each serve different purposes and are used for different types of data. The stem and leaf breaks apart the data into what are known as stems and leaves, and the box plot is great for showing the distribution of data when using the quartiles and the interquartile range and the median. We'll learn more about those in another lesson, but I just wanted to give you an idea of what was coming up later in a different lesson and what you might see in another class. So, for now, let's just focus on the histogram, the frequency polygon, and the ogive.